Hi, welcome to this problem on number patterns arithmetic series. Let's have a look at question 3 on solving an arithmetic series problem. Without a calculator, calculate the following expression. And this is a fractional term, right? The numerator is 4 plus 8 plus 12 plus 16, all the way up to plus 100. The denominator is 3 plus 10 plus 17 plus 24, all the way up to 101. Okay? If you had even thought initially, I'm just going to do 4 plus 3, 4 over 3, divide, then add 8 over 10, then add, I will not be happy. Okay? We can't do that. It's separated by plus or minus signs in the numerator and denominator. So we can't just do that kind of willy-nilly kind of algebra. We have to do this carefully. So, if I look at the numerator terms, that actually looks like an arithmetic series, okay? Because the sequence looks arithmetic. So let's have a look at the numerator terms, which I'll denote by capital N. 4 plus 8 plus 12 plus 16 plus all the way up to plus 100. So this looks like term 1 plus term 2 plus term 3 plus term 4, all the way up to, I don't know what that last term is. It could be the 10th term, could be the 13th term, could be the 70th term, okay? But what's cool about this is that you know that this is the first term, A, and you know that this is the last term, L. So we might end up using the second series formula here. But we still need to know the number of terms. So we need to find out what term or what position will give us a value of 100. So we're on the right path so far. For the denominator, it looks similar. It's 3 plus 10 plus 17 plus 24 all the way up to plus 101. Well, that's term 1 plus term 2 plus term 3 plus term 4 all the way up to term n. Again, we don't know what this n here for this sequence is. It could be the 7th term. It could be the 20th term. It could be the 15th term. We actually don't know, but we can work it out. So for the first one, let's have a look here. T sub n. This is a plus n minus 1 times d, where n is a natural number. But we know that a is 4, and this common difference looks like it's just adding 4 the whole time. So it'll be plus n minus 1 times 4. Okay? I can clean that up a little bit, which I think I'm going to do. So that's 4 plus n times 4 is 4n. Negative 1 times 4 is negative 4. The 4 and negative 4 will cancel, and I'm just left with Tn equals 4n, where n is a natural number. Okay? So how do I know which nth term gives me 100? Well, I have to substitute 100 here equals 4n, and divide both sides by 4, therefore giving me n equals 25. So there are 25 terms here in the numerator expression. So 25 terms. 4 plus 8 plus 12 plus 16. You're adding up 25 terms in total. What about the denominator? The common difference here looks like positive 7, because I'm adding 7 each time to get to the next term. So Tn equals a, which is 3, plus n minus 1 times 7, where n is a natural number. I'm going to clean that up a bit. So it's going to be 3 plus n times 7 is 7n. Negative 1 times 7 is negative 7. So therefore I get Tn equals 7n minus 4. Now I want to find that n position that gives me 101. So therefore I'll get 7n equals 105. All I did was just add 4 to both sides. If I divide both sides by 7, I therefore get n equals, let's bring up the calculator, 105 divided by 7, and I get 15. So there are 15 terms here in the denominator. So there's 25 terms in the numerator and 15 terms in the denominator. Okay, now that I have my n for both, I have an a value for both and an L value for both, I'm going to use the second series formula. So this is going to be numerator divided by denominator, which is equal to in the numerator, you're adding up the first 25 terms, S25, divided by, you're adding up the first 15 terms here for that other sequence. But let's have a look. S25 for this first one here is going to be n divided by 2 times a, which is your, so just recall I'm using this formula here. Sn equals n over 2 times a plus l. That is the formula I'm using because I know the number of terms I'm adding up. I know the first term and I know the last term. So 25 over 2 into the first term is 4 and the last term is 100. So this is 25 over 2 times 104. 2 goes into 104 52 times. So it's going to be 25 times 52. So let's do that. 25 times 52. And I get 1,300. Okay. What about S15 for the bottom terms? Well, that's going to be 15 divided by 2 into the first term here was 3. And the last term was 101. So it's 15 over 2 times 104. But again, if I look at 2 going into 104, that's 52. So 52 times 15. So let's bring that up. 52 times 15. That's 780. So therefore, the final answer is 1,300 over 780, which if you put into your calculator, will simplify down to 1,300 divided by 780, which will give you 5 over 3. So that whole long sum, 4 plus 8 plus 12 plus 16 all the way to plus 100, all divided by 3 plus 10 plus 17 plus 24 all the way to the last term, 101. Doing each term separately, the numerator and denominator, as you should always do whenever you're dealing with any type of fraction, you look at the numerator on its own first and simplify it. You look at the denominator on its own and simplify it. Then you do the division. And in this case, at the end result, we have 5 over 3, which is our final solution. All right, I'll see you in the next one.